Columns play an important role in a building structure. The main function of them is to transfer the loads from slabs and beams to the foundation of the structure and finally to the soil underneath. This video is going to be very much helpful to those students who want to learn how to calculate the quantity of steel required for a column and how to prepare the bar bending schedule of a column. Let's illustrate this whole procedure with the help of an example. Suppose we need to calculate the quantity of steel required for the column of a two-story building with the given dimensions. The size of column is 300 into 450 mm. Clear cover of column is 40 mm. We have provided 4 number of main bars of dia 16 mm and 2 number of side bars of dia 12 mm. The footing main bars and distribution bars are of size 12 mm. Footing cover is 50 mm. Excavation depth is given as 1.7 meter. Sand filling 100 mm. PCC 100 mm. Plinth height is 500 mm. Floor to floor height is 3 meter. Number of floors is 2. Thickness of slab is 150 mm. And number of intermediate slabs is 1. To calculate the total quantity of steel, we need to do the calculations for each type of bar separately. Since this column is provided with 3 types of bars, that is main bars of size 16 mm, side bars 12 mm and ties of size 8 mm. Now let's start with the calculation of main bars. The cutting length of main bars will be equal to excavation depth minus sand filling minus PCC minus footing main bar minus footing distribution bar plus plinth height plus floor to floor height into number of floors plus slab thickness plus slab length plus twice development length minus bend deductions. Excavation depth is 1.7 meter, sand filling 100 mm, PCC 100 mm, footing main bars 12 mm, distribution bars 12 mm, plinth height is given as 500 mm, floor to floor height is 3000 mm, number of floors is 2, the slab thickness is given as 150 mm, lap length will be equal to 50 times D, that is 50 times 16 mm, the development length is equal to 49 times D, where D is the diameter of the bar, and bend deductions will be equal to 2 times 2D, where 2D is the bend deduction for 90-degree bend, since the bar is bent at both of its sides by an angle of 90 degree. On substituting all these values, the cutting length of main bars will be equal to 10.4 meter. The total length of main bars will be equal to number of main bars into cutting length. Number of main bars is 4 and cutting length is 10.4. On substituting these values, total length of main bars will be 41.6 meter. Now we need to calculate the unit weight, which is given by the formula d square by 162.2, where d is the diameter of the bar, that is 16 mm. On simplifying further, unit weight will be equal to 1.58 kg per meter. The total weight of main bars will be equal to unit weight into total length. Unit weight is already calculated as 1.58, total length is 41.6 and the total will be 65.7 kg. Now let's do the calculations for side bars. The cutting length of side bars will be equal to excavation depth minus sand filling minus PCC minus footing main bars minus footing distribution bar plus plinth height plus floor to floor height into number of floors plus slab thickness plus lap length plus twice development length minus bend deduction. On substituting all these values, the cutting length of side bars will be equal to 9.8 meter. Total length of side bars will be equal to number of bars into cutting length. Number of side bars is 2 and the cutting length is 9.8 meter. On substituting these values, the total length of side bars will be 19.7 meter. The unit weight of side bars will be equal to d square by 162.2, where d is 12 mm and the total will be 0.89 kg per meter. The total weight of side bars will be equal to unit weight into total length of side bars. Unit weight is already calculated as 0.89 and total length is 19.7. On substituting these values, total weight of side bars will be 17.5 kg. Now let's do the calculations for lateral ties. First of all, we need to calculate the number of ties, which is given by the formula height of column upon spacing plus 1. The height of column will be equal to excavation depth, that is 1.7 meter, minus sand filling, which is 100 mm, minus PCC, which is 100 mm, minus footing main bar, minus footing distribution bar, plus plinth height, plus floor to floor height into number of floors, plus slab thickness. And the spacing is given as 150 mm. On substituting these values, the number of ties will be 56. Now we need to calculate the cutting length of ties, which is given by the formula twice a plus b plus twice 10d minus 3 times 2d minus 2 times 3d, where a is the center to center distance between the extreme vertical bars of the ties along the width of the column, and b is the center to center distance between the extreme horizontal bars of the ties along the depth of the column. A will be equal to width of column minus twice clear cover minus 2 times d by 2, where d is the diameter of the ties. Width of column is 300 mm, clear cover is 40 mm, and d is 8 mm. On substituting these values, a will be equal to 212 mm. B will be equal to depth of column, that is 450 mm, minus twice clear cover minus twice d by 2. On substituting these values, B will be equal to 362 mm. 10d is the hook length, where d is the diameter of the bar. 2d is the formula for 90-degree bend, which is 2 times 8. 3d is the bend reduction for 135-degree bend. On substituting these values in the previous equation, the cutting length of ties will be equal to 1.212 meter. The total length of tie bars will be equal to number of ties into cutting length. Number of tie bars is already calculated as 56 and cutting length is 1.212. On substituting these values, the total length of tie bars will be 67.87 meter. Unit weight will be equal to d square by 162.2, where d is 8 mm and the total will be 0.39 kg per meter. Total weight of tie bars will be equal to unit weight into total length of tie bars. Unit weight is 0.3, total length is 67.87 and the total will be 26.47 kg. Finally, the total weight of steel will be equal to weight of main bars plus weight of side bars plus weight of ties, which will be equal to 109.6 kg. Adding 5% of wastage, which will be equal to 5% of 109.6, equal to 5.48 kg. The gross weight of steel required will be equal to total weight of steel plus 5% wastage, and the total will be 115 kg. Hence, the total quantity of steel required for this column